Hey guys, this video is for junior high science, the highlights for pages 284 to 288. So let's look at page 284. We're looking at atoms, the building blocks of matter. So highlight the definition for atom. All matter is composed of tiny particles called atoms. So we can't see them, but it is what makes up every solid thing. Even you. So we have the example of a penny there. So how many atoms of copper would a single copper penny contain? The answer is nearly 30 billion trillion atoms. That's a 3 followed by 22 zeros. If you could count a billion atoms per second, it would still take you 950,642 years to count that many atoms. So just imagine how many atoms would be in something like a car or even in you. On the next page, let's look at the anatomy of an atom. Find the bold term nucleus. Around that, highlight. At the center of the atom is a tiny, extremely dense core called the nucleus. Keep highlighting. Around the nucleus swarms from 1 to over 100 tiny particles called electrons. So if you look at the diagram at the bottom of that column, you can see how that works there. We have the nucleus in the center. It's made up of the protons and the neutrons, which we'll talk about in just a second. And then we have the electrons that kind of just spin around it. So let's look at the next column. Highlight the electrons zooming about a nucleus form a shield that prevents other atoms from moving into the same space. And then connect that to the bold term electron cloud. So we call those electrons that spin about. On the bottom of the page, find where it says the central nucleus. Highlight the nucleus of an atom is a cluster of separate particles. These are of two kinds, neutrons and protons. So in that picture there, we can see the neutrons, protons, and electrons. And they look kind of like a bunch of grapes in the picture, but the truth is we're not really sure exactly what those things look like because they're so tiny. So you can see the protons and the neutrons making up the nucleus, and then we've got the electrons spinning around outside. Turning the page, our next highlight is all the way down the bottom of the first column. And we're talking about positive and negative charges. Highlights the bold words, opposite charges attract, like charges repel. Highlight that the proton is positive and the electron is negative. This means that they are attracted to each other. So you can see our picture there with our little turtles. Like charges are repelling, so if you have a positive and a positive, they're going to repel each other. If you have a negative and a negative, they're going to repel each other. You get the positive and the negative, and they are attracted. It's kind of like taking two magnets, and you put the ends together, and if you have the same poles coming together, the magnets are going to push away from each other. You're going to have a hard time getting them together. But if you flip one around and you get the opposite pole, then they're going to stick together. So know that the protons are positive, the electrons are negative. A bit further down that column, find where it says a normal atom. So highlight that. A normal atom has an equal number of protons and electrons. So the idea there is that they're kind of balancing each other out. The very bottom of that paragraph, you should see the bold term neutral. Highlight anything lacking an electrical charge is said to be neutral. So we can see our chart at the very bottom of the page. We have the electron, that is negative, so we have the negative sign. We have the proton, that's positive. The neutron comes from neutral. It has no charge. So easy way to remember the neutron is neutral. Under the structure of some common atoms, highlight the simplest kind of atoms have a single electron with a single proton. And highlight that this is the main building block of a substance called hydrogen. So we have an example of that there. We've got the hydrogen atom, single proton being wrapped around by a single electron. So simplest kind of atom there. We've got some other kinds of atoms shown on the other page. We've got a helium atom, a carbon atom, and a sodium atom. So different kinds illustrated there. On page 287, find the bold term shell. Before that, highlight electrons in orbit at roughly the same distance from the nucleus are said to be in the same shell. So know that definition for shell. And then turn the page to page 288. Highlight the number of protons in an atom is the atomic number. That's what we call it. The atomic number is the number of protons in an atom. And then highlight the bold words at the very end of our section there. Every element has its own atomic number. So a carbon atom that has 6 protons would have an atomic number of 6. Copper has an atomic number of 29 because it has 29 protons. And gold with 79 protons has an atomic number of 79. So as we get into our elements and those different things tomorrow, we will see the difference in each of those numbers. So I hope you guys were able to get the important things here and make sure that you are getting your work done, and let me know if you have any questions. Have a great day.